In this video, we're going to be looking at another challenge problem from Chapter 8. This is 8.8, Simulate a Coin Toss Experiment. In this challenge problem, it wants us to write something that can determine, on average, how many times you need to flip a coin before you get a different answer. So for instance, if you flipped a coin and it was heads, you flip it again and it's heads, you flip it again and it's heads, and then you flip it the fourth time and it's tails. In that case, it took 4 times before you got a different result. If you flipped it once and you got tails, and you flipped it a second time and got heads, in that case, it only took 2 flips. So it wants us to do this, a simulation that runs 10,000 times and prints the average number of times it takes before you get a different result. So since we're going to be using random numbers here to generate a heads or tails, we're going to be needing the random module. So this is introduced in Chapter 8, and you import a module in Python by import and then the name of the module. What that'll do is it'll allow us to call the random functions. So before we do this 10,000 times, let's see how we're going to do it a single time. So first, before you flip any coins, your number of heads is going to be 0 and your number of tails is going to be 0. So let's write these as heads equals 0 and tails equals 0 as variables like that. Now you're going to keep flipping while at least one of them is 0. So for instance, if you flip and you get a heads, that means that's 1. And then you get another heads, that's 2. And another heads, that's 3. And so on until you finally get a tails. And then if they're both not 0, then at that point you know that, okay, both of them have now been flipped. So put these back to 0. And to do this, we're going to check while heads equals 0 or tails equals 0. So as long as one of them is 0, as long as we don't have any heads or we don't have any tails, we're going to keep flipping. So we use the while keyword and then our condition and then the colon. Now everything inside here indented is going to be run each loop. So now let's simulate a coin toss. We're going to store that into a value we'll just call toss result. And we're going to be calling there's several different ways to do this. We basically just need something that'll give us a 50-50 chance. So we can do random.randint, and we can do 0, 1. And what that'll do is it'll randomly choose between 0 or 1. There's our 2 results right there. Now, if the result was 0, let's call it heads. And again, this is going to be toss result, sorry. Okay. Otherwise, so else, tails, we're going to increment tails. And we don't have to actually increment it by 1 each time. We could just set it to 1 because if we get 5,000 heads in a row, it doesn't matter. We'll still be keeping track of how many iterations our loop has taken. But let's go ahead and do this. Okay, so as soon as one of those is no longer 0, this while loop will end. So now we need to do this 10,000 times. So instead of hard coding 10,000, let's do this. Let's say number of trials, and we'll say 10,000. Oops, we don't need 0. Well, we could put a comma there, or not. So now we want to loop 10,000 times. So our syntax for our for loop is for, and then our variable we're going to use for iterator, so we'll just say number in range. Now it's inclusive, so 1 through exclusive. So it's actually going to be number of trials plus 1. So that we'll get 10,000 trials. And then we put our colon. And now everything indented inside of here is going to be executed in our for loop. So every time we're ready to start a new trial, we want to reset heads and tails. And then we want to execute this while loop again. So to put this inside the for loop, I'm just going to indent everything, because everything indented here is going to be run inside the for loop. Now we also want to keep track of how many total tosses we have. So in this case, we're going to say every time our number of flips changes, okay. So the number of flips it takes is going to be this number of times. So what we'll do is we'll say number of times equals 0. So then let's say it takes 3 times till we get a different result. So the number of times by the time we exit out of here will be 3. We can say total flips start off at 0. And then after we're all done, we can increment our total flips by the number of times it took to get a different answer. Now, there's a shortcut we can do here. Since every loop through, we're incrementing that, and then we're taking the total sum and adding it to total flips, we can actually just do it on every single flip. Just increment the total number of flips. So now, what that'll do is that will run 10,000 times. So lastly, we need to figure out, on average, how many times we have to flip for each trial. So we can say is the average equals the total flips divided by the number of trials. And then we can print the result using string interpolation. On average, it takes average flips. Let's go ahead and run this. Let's run this with something much shorter just in case. So let's run this 5 times. So on average, it takes 4 flips. So to see what's happening inside of here, let's do this. Let's do some print statements. And this is a technique that you'll see in chapter 7. We're going to print flip result. Actually, here, let's say starting new trial. All right, inside here, let's say print toss result, and that's going to be toss result. And this one, I'm not actually interpolating anything, so I can get rid of the F there. Let's see what this looks like. Okay, so on our first trial, our first toss was heads, 0. The second toss was 0. The third toss was a tails. So in this case, it took 3. So in the second case, it took 2, and then 2, and then 2, and then 3. So to get the average, we add all the numbers up. So 3 and 2 is 5, and 2 is 7, and 2 is 9, and 3 is 12. We're going to divide that by the total number of trials, 5. So 12 divided by 5, 2.4. So now we can get rid of these print statements, because if we did 10,000, then that would be a lot of printing on the screen. So now let's go ahead and run it with 10,000. 3, 4.4, 2.2, 2. So we can run this as many times as we want. Each time it'll give us different values. Okay, so that's it for this problem. If there's any questions on it or any questions on the chapter in general, feel free to email me or start a discussion in Canvas. Thank you.